students. Here, find the analytic function whose imaginary part is v is equal to log x square plus y square plus 2xy. To find the analytic function, first we have to find out its real part. For that, first we have to show that v is harmonic. To show that v is harmonic, we use the formula vxx plus vyy is equal to 0. vxx plus vyy equals 0. First, we can find vx, partially differentiating with respect to x. 1 by x square plus y square into 2x by x square plus y square plus 2y. This is the value of vx. Similarly, value of vy. Vy is equal to 1 by x square plus y square into 2y plus 2x. This is the value of vy. Then find vxx. Vxx is equal to x square plus y square into 2 minus 2x into 2x divided by x square plus y square the whole square. Then vyy. Vyy is equal to x square plus y square into 2 minus 2y into 2y divided by x square plus y square the whole square. That is, this is equal to y square 2y square minus 2x square by x square plus y square the whole square. Here 2y square. Here 2x square minus 2y square divided by x square plus y square the whole square. Therefore, uxx plus uyy. Uxx 2y square minus 2x square, a common denominator, x square plus y square whole square common denominator. Numerator 2y square minus 2y square cancel, 2y square cancel, 2x square cancel. Therefore, answer is 0. Therefore, we can say that and the function u is harmonic. Next, we have to find out its real part u. We have to find out. To find out u, we use the Cauchy-Riemann equation. We use the Cauchy-Riemann equations. We use the Cauchy-Riemann equations. The first Cauchy-Riemann equation is ux is equal to vy. Vy is equal to 2y by x square plus y square plus 2x. Then integrating with respect to x. Integrating with respect to x. That is u is equal to, integrating with respect to x, u is equal to 2y by x square plus y square. We know that integral of dx by x square plus y square is equal to 1 by a tan inverse x by a. Here, a is equal to y. Y is equal to a. Therefore, we can apply the formula 2y into 1 by y tan inverse x by y. X by y plus then 2x plus 2x square by 2 plus pi of y. That is, u is equal to, real part is equal to, y we can 2 tan inverse x by y plus x square plus pi of y. This is known as u. Therefore, here the real part u is equal to 2 tan inverse x by y plus x square plus pi of y. Next, we have to find out the value of pi of y. For that, we differentiate this equation. With respect to x. With respect to y. We differentiate with respect to y. Therefore, uy is equal to, differentiating this equation with respect to y, uy is equal to 2 tan inverse 2 tan inverse x by y. When we differentiate with respect to y, tan inverse x by y is equal to 2 into 1 by x square by y square into x into minus 1 by y square plus x square, that is equal to 0, plus pi dash y. That is uy is equal to 2 into 1 by x square plus y square into x into y square, x into minus 1 by y square plus pi dash y. This y square will be cancelled. Therefore, we get minus 2x by x square plus y square plus pi dash y. Plus pi dash y. That is uy. That is uy. Then we use the second Cauchy-Riemann equation. We can use the second Cauchy-Riemann equation. Uy equal to minus vs. Uy is equal to minus 2x by x square plus y square plus pi dash y. Vx is equal to minus of 2x by x square plus y square plus 2y. Vy is equal to Vx is equal to 2x by x square plus y square plus 2y. This 2x by x square plus y square, 2x by x square y square cancels. Therefore, pi dash y is equal to minus 2y. Pi dash y is equal to minus 2y. Therefore, we integrating this one, integrating pi of y is equal to minus 2y square by 2, 2 to cancel, plus c. Therefore, the value of pi of y is equal to minus y square plus c. Therefore, in this case, u is equal to, therefore, u is equal to 2 tan inverse x by y plus x square minus y square plus c. This is the real part. This is the real part. Here we have to find out the value of, function f of z. F of z is equal to u plus iv. Here u is equal to 2 tan inverse x by y plus x square plus y square plus c plus I into v. Given v is equal to log x square plus y square plus 2xy. This is the required analytic function.